Hello, everybody. So in the last lesson, in 7.05, we introduced this idea of finding length using trigonometry. And we just presented the acronym for trigonometry. In this lesson, we're going to actually talk about how to solve triangles using trig, okay? So with that said, that's exactly what the objective is. I can find the side lengths of a right triangle. Before we get into it, remember the acronym. The acronym is SOHCAHTOA. Well, how do you spell that? How do I know how to spell that? Well, in each of the three functions, sine, cosine, and tangent, they each represent a relationship between two different sides. So if you're thinking about a triangle, and you have an angle here, right? You have this angle. You identify your opposite side, your adjacent side, and your hypotenuse side according to that angle. In sine, you're dealing with one relationship. In cosine, you're dealing with another relationship. And with tangent, you're dealing with another relationship. So it's a combination of two out of the three, okay? So if you find yourself, when you go to spell it out, repeating the same two letters, then something's wrong, okay? So to me, I think about it, the easiest one to sound out, to enunciate, is toa, toa, oa, oa, oa. And so that eliminates the combination, because we can only have a certain amount of combinations. Those are the three combinations we can have. If I'm talking about tangent, that eliminates this set. The next set is so. That's the easiest one out of the remaining two. So, o, o. So that has to be the one with the O. And then ka, ka, you could say ka, toa. Okay? So that might be a way to help you remember how to spell it. But so, ka, toa. And remember, it's an acronym that represents relationships. Okay? All right. With that said, let's go ahead and create the ratios according to this triangle. So I'm going to use the names of the sides now instead of variables. We're going to just use the names of the sides. So for example, this side is named RQ, the distance from point R to point Q. This side is QS and this side is RS. So if I want to identify the sine, the cosine, and tangent of the angle 57 degrees, I've got to identify the three sides. So remember, if I'm talking about 57 degrees, the opposite is the one that is furthest away from it. It's the side that is not touching that angle. This angle is S, so RQ is opposite to it because it's not touching S. The adjacent side is the side that touches S, but that is not the hypotenuse. In other words, it's the side that has the two angles, so the 90 degrees and the 57 degrees. And obviously the hypotenuse is the hypotenuse, okay? So if I want the sine of 57, remember it's always the sine, the cosine, or the tangent of the angle, and in this case the angle is 57 degrees. If I want the sine of 57, I would say, okay, sine is opposite over hypotenuse, so the opposite here is RQ, and then the hypotenuse is RS, right? And if you put QR on top, that's the same thing. RQ and QR are the same thing. If you put SR on the bottom, that's fine, okay? Now if I want cosine of 57, cosine of 57 is adjacent over hypotenuse, so it would be QS over RS. And then the tangent of 57, that's going to be the opposite over the adjacent, so that's going to be QR over QS, or RQ over QS, okay? Now that is if I'm talking about the angle S, the 57 degree angle. But what happens if I want the sine of 33, the cosine of 33, and the tangent of 33? Well, where'd the 33 come from, right? You're going, where is that? I don't see 33 anywhere in here. Well, remember, the three angles add up to 180. So 90 plus 57, if you add those together, that's 147. And if I subtract that from 180, I actually get this angle here that's 33 degrees. So that's why I'm asking for the sine, the cosine, and the tangent of 33. But if I'm talking about 33 degrees and not 57 degrees, then we have to ask ourselves, are these three labels in the correct place? Is this side opposite to 33 degrees? The answer is no. This side is opposite the 57. So I can't call this the opposite and the adjacent and the hypotenuse if I'm talking about 33 degrees. So I need to erase those things and replace them with the correct values. Notice h doesn't change. The hypotenuse is always the hypotenuse. But if I'm talking about 33 degrees, the opposite to 33 is this side over here. So I'm going to put an O there and then an A next to the 33 degrees. So then sine of 33 would then be QS over RS. Cosine of 33 would be RQ over RS. And then tangent of 33 would be QS over RQ. Okay? So just be aware that you have to make sure that you are identifying the angle that you're using and then using the appropriate sides according to that angle, right? If you're using 57 degrees, it's a different set of opposite and adjacents than if you're using the 33 degrees. All right, with that said, let's go ahead and solve a problem. Let's actually solve a problem here, and I'm going to give you a bunch of steps here to be able to solve these. So I've got two examples here, A and B. The first thing I want to do when solving these is to identify the side lengths. What do I mean by that? Identify our opposite, our adjacent, and our hypotenuse. And that is based on the angle that's given. So since the 28 degrees is given, we're going to identify the thing that I want and the thing that I have. Well, what's the thing that I want? The thing that I want, the x, is the adjacent side, right? The adjacent side. Oops, I should write that down here. Actually, let me go ahead and draw a picture of this. Okay. All right, so I've got 28 degrees, I've got x, and I've got 12. Well, which side is the adjacent? The x is the adjacent side, so I'm going to put an A there. And the 12 is the hypotenuse, so I'm going to put an H there, okay? So that's step one, identify the side lengths. Step two is to determine the appropriate trig function, right? Which operation, which function are we going to use? Well, we got to write down our acronym, right? Let's write down our acronym here. Our acronym is SOHCAHTOA. Okay. Now, which trig acronym am I going to use? Well, if I'm asking for x, if I'm asking for the adjacent side, I'm not going to use sine because that doesn't have adjacent. And if I have the hypotenuse, that means I'm not going to use tangent, so I'm going to use cosine, okay? So I'm using cosine. Step three is to create the equation. Well, what's the equation? Remember, it is going to be cosine of the angle. What's the angle? The angle is 28 degrees, is equal to the adjacent side, so in this case is x, over the hypotenuse side, which is 12. So there I've set up the equation. Cosine of 28 is equal to x over 12, okay? Step four is then to solve the equation. Now this is just algebra. And you go, well, how's this algebra? I got this cosine I've never dealt with before. That's why you use a calculator, okay? So I've got my calculator here. I've got my calculator, and actually I should move this screen over so we can see it. We don't run out of room when I'm writing here, okay? All right, so how do I use my calculator to determine this? Well, the first thing I want to do is figure out what the cosine of 28 is. Now, in this calculator, I'm going to type in cosine of 28, and then I'll close my parenthesis, and I'll hit enter, and I'll get my number. It's 0.883 is what I'll round it to. So this is going to be 0.883, and that's equal to x over 12. Now, depending on the calculator that you have, some calculators want you to input the information differently. So I have my iPhone here, okay? And I want to figure out the cosine of 28 with my iPhone. And a lot of calculators work this way. You can't just type in, there's a cosine button right there. You can't just type in cosine and then 28. It doesn't work, okay? So what you need to do here is type in 28, and then you're telling the calculator to take the cosine of 28. And so you can see that I got 0.883, okay? So just depending on the calculator that you have, obviously you shouldn't be using your phone on any kind of test. So you want to get used to using a regular old calculator, okay? But in my case, cosine of 28, and I wrote that down, 0.883. Now from here, how do I solve this? Well, the best way, the simplest way to see this is to set up proportions just like we've been doing proportions all along. I've got a fraction on this side, so let's go ahead and put this as a fraction. And then we cross multiply like we normally do. So we'd say 0.883 times 12. And so I have that stored in my calculator. I got that number right there. So I can just hit times 12 and then hit enter. So I end up with 10.595, okay, for that one. And then when I go to cross multiply this side, I end up with x times 1, which is just x. And there I've just found the value of x, okay? And obviously, depending on, if you want to round to the nearest whatever, it'll say, and this is rounded to the nearest thousandth, okay? So that is A. Let's go ahead and take a look at B and see if we can come up with this together, because sometimes this takes more than once to see what's going on, okay? So I'm going to draw the triangle. I've got 56 degrees here. I've got x, and I've got 14, okay? So the first step, step 1, is to identify our side lengths. So what is the x? Well, the x is between the angle and the 90, so this is my adjacent side. The 14 is opposite to the 56, that's my opposite side. And obviously this side is the hypotenuse, but I don't care about that side because I'm not asking about it and nothing's given there, right? So then I go to my acronym, my SOHCAHTOA, right? Which one has the A and the O in it? Well, A and O, TOA, that's tangent. So I'm going to use tangent. And so I've identified the appropriate trig operation. Next is to create the equation. So it's tangent of the angle, in this case, tangent of 56 degrees, is equal to opposite over adjacent. So in this case, it'd be 14 over x. Let me go ahead and write that out again. SOHCAHTOA. We need to make sure that we're setting up the ratios according to the correct numerator and denominator. Okay, so tangent is opposite over adjacent. So you'll notice a difference in these two equations. In the first equation, the variable ended up on top. Okay, in this equation, the variable ended up on the bottom. You're still going to approach it the same way, but you can't just assume the variable is always going to be on top. You have to make sure that the ratio here, the fraction that you write, is correct according to the acronym. Okay. So from here, we're going to type in the tangent of 56. So I'm going to say tangent 56. You can see sine, cosine, tangent there. And I end up with 1.483 when I round it. So on this side, I get 1.483. And then on this side, I get 14 over x. From here, we'll cross multiply. So we're going to put this over 1 and then multiply. Notice I'm not multiplying 1.483 times 14. I'm multiplying it times x, so it becomes 1.483x equals 14 times 1. Well, that's 14. And now I'm not done yet because I need to get x by itself. So how do I get x by itself? I would need to divide by 1.483 on both sides. Okay, so this side reduces to x, and then I'm going to use my calculator again, and I'm going to say 14 divided by 1.483, and then hit enter. So my answer here is going to be 9.440. Okay, so that is the length of that particular missing side. Now I could find the other side by doing the Pythagorean theorem or doing another trig operation, to be honest with you. Okay, so there are two examples of what it looks like to solve a right triangle by using trigonometry. Okay, so let's go ahead and do some practice here. I want you guys to do these next few problems, 2 problems here on your own, and see what you come up with, okay? All right, for number 4, we have a right triangle, hopefully, because that's really all we're dealing with when we're talking about trig in this year. We got 47 degrees, we got x, and we've got 5. So first of all, the 5 is our adjacent, and the x is our adjacent, and the 5 is our hypotenuse. So that should be cosine of the angle, so in this case, cosine of 47, is equal to adjacent, which is x, over hypotenuse, which is 5. From here, we're going to type in the cosine of 47 and get a number. So we get 0.682 equals x over 5. And then we're going to put that over 1 and cross multiply. So 0.682 times 5, well, I've already got that in my calculator, so I'm just going to hit times 5, and then I end up with 3.410 if I round it. And then x times 1 is going to be x. And that's it, because I have x already by itself. I'm done. That is my answer for number 4. Okay. For number 5, we've got a right triangle there in that corner, a y, a 17, and a 78. Well, identify our sides. The y is an adjacent side. The 17 is the opposite side. So that's going to be tangent of 78. Tangent of 78 is equal to opposite, so 17, over adjacent, so y. And then from here, we're going to use our calculator to find tangent of 78. Tangent 78 is equal to 4.705. And then from here, we'll put it over 1, cross multiply. So we end up with 4.705y equals 17 times 1 is 17. And then we'll go ahead and divide by 4.705. 4.705. So we end up with y equals, well, calculator time, 17 divided by 4.705. We end up with 3.613, and that is our final answer for that missing side. Okay, so that's the basics of how to solve a right triangle, or at least one part of a right triangle. Okay, we have one more problem to do, and it's a little bit more in depth. And the reason it's more in depth is because if you notice in number 4 and 5, I only found one thing. But how many pieces are there to a triangle? Well, in a triangle, we have 3 angles, right? And we have 3 sides. I know 2 of the angles, so I could find the missing angle. I know how to do that already. That's the triangle sum theorem. And I used the trig stuff to find this missing side, but I still didn't answer the question for this missing side. So when we're solving triangles, usually we want to find all the missing pieces. So there's 3 angles total and 3 sides total. And that's the point of this problem. We want to find all of the missing pieces that are there, okay? So go ahead and pause the video, see what you come up with, and then push play to compare your results with what I get here, okay? All right, for this problem, we are finding all the missing pieces, okay? So we've got a right angle here. We've got 49 degrees. We've got 21, and then we've got A, C, and B. Don't let those capital letters frustrate you or confuse you. If you're looking at the question, the first question says, what is the length of AB? What is this length here? So what you could do to help out is just to put an X there. That's what we're looking for AB. For question number 2, it's asking for the length of AC. So we're looking for this side. So we'll call this Y because it's not the same thing, right? And then the last thing, it says, what is the measurement of angle B? So actually we're looking for this angle here. So I'm going to go ahead and call this A for angle, okay? Now, I'm going to skip around here because question number 3 is the easiest question to solve, okay? Question number 3, we want to find that missing angle. What do we know about the 3 angles? We know that the 3 angles add up to 180. So we could say sorry, I wrote that wrong. We would say 49 plus 90 plus A equals 180 because 49, 90, and A. So that's 139 plus A equals 180. And then we're going to subtract the 139 from both sides. And we're going to end up with A equals 41, so 41 degrees. So that is actually the question number 3 there, okay? That's the easiest one to solve. It's just adding and subtracting, right? But let's go back to number 1 now. Number 1 says find the length of AB. Now, I could use the 41 degrees that I just found, but I'm going to use what's given to me. So I'm going to talk about the 49 degrees, okay? If I'm looking for the length of AB is my hypotenuse. 21 is my opposite according to the 49 degrees. And then y is my adjacent according to the 49 degrees, okay? But for question number 1, it's asking for AB. So I know that I need to have an equation that has a hypotenuse in it, and I need a non-variable. So I need to have, I can't use y, because then I'd have two variables, okay? So I want to use this side, the opposite. So I want to use an equation that has h and o in it. So I'm going to use sine. Sine of the angle, so sine of 49 degrees, is equal to the opposite, which is 21, over the hypotenuse, which is x. And then we'd solve it from there. So we type into our calculator, like always, sine of 49. We end up with 0.755 equals 21 over x. Then we'll put it over 1 and cross multiply. So we end up with 0.755x equals 21 times 1 is going to be 21. And then we'll divide by 0.755 and get our answer. Okay, so those would reduce. We got x equals, and then 21 divided by 0.755 ends up being 27.815. Okay, so that is x. And what was x? X was the name that we used for AB. So we would conclude that AB is equal to 27.815 as our final answer for that one, for question number 1. Okay. All right. We have one more thing to do. That's number 2. Number 2 says find the length of AC. So I called it y. Now at this point, you have a whole slew of options to solve for AC. You could do the Pythagorean theorem because you have one side here. You know this side now, so you could do the Pythagorean theorem. But this number here is a rounded number, so I want to kind of avoid that if I can. I want to use a trig operation using the original things given. So I want to use the 49 and I want to use the 21. So if I'm looking for y, that's my adjacent. If I have 21, that's my opposite. So adjacent and opposite are going to end up giving me tangent. So it would be tangent of the angle. So in this case, tangent of 49 is equal to the opposite, which is 21, over the adjacent, which is y. Okay? We'll type in tangent of 49. So tangent 49, that's going to be equal to 1.150. And that's equal to 21 over y when I carry that down. Oops. And then we'll cross multiply. So we end up with 1.150y equals, and then 21 times 1 is 21. And then we'll divide by 1.150 on both sides. And then solve. So y equals, let's see, 21 divided by 1.150. We end up with 18.261. So our final answer would then be AC is equal to 18.261. Now, what I'm going to do is I'm going to redraw this triangle because I want to make sense of this. I want to make sure that my answers are making sense. I've got 49 degrees for this guy. That was given. And then A was 41 degrees. That was something I solved for in number 3. This side is 21. AB, which is this side, is 27.815. And then AC was 18.261. So let's make sense of this and make sure that this makes sense, okay? Remember, the hypotenuse has to be the longest side. That's just guaranteed. If the hypotenuse isn't the longest side, then we did something wrong. We can see that the hypotenuse here is bigger than the other two sides. It's 27.815. So that part's good. The next thing we want to check is to make sure that the smallest length, so the smallest length is the 18.261. The smallest length needs to be opposite to the smallest angle. So 41 and 49 degrees, 41 degrees is smaller, so that should be opposite to the smallest side. And 21 is bigger than 18, so it should be opposite the bigger angle out of the two. And it is, right? And obviously the biggest angle, which is 90, is opposite to the biggest side here. So we know that we can have confidence that we did something right because those lengths are appropriate to the angles that they correspond with, okay? All right, so that is how you solve for missing sides of right triangles using trig. If you have any questions, please reach out to me so I can help you out. I'll see you again next time.